Okay guys, in this video we're going to check out evaluating functions a little bit further, but go a little bit deeper into that topic. So the first thing we want to do, we're going to start with the function, and that function looks like this. It's just a linear function, it's a line. And so we can kind of go through, and we know a couple things when it's in this form. We know that this guy right here is going to tell us about where the y-intercept is, and this guy right here is going to tell us the slope. So slope is 2 over 1. So we can go through and we can plot this pretty easily. So -2 is the y-intercept. My slope tells me to go up 2, 1, 2 over 1. So I got another point right here, up 1, 2 over 1. So my line looks something like this. Something like that. Okay, so what we want to do is we just want to start off, I want to give you a little reminder of what it means to evaluate. So to evaluate just means wherever I see an x, I'm going to plug in whatever number is in here. So this means f of 3. So it's read f of 3. And this just means plug 3 into x. Wherever I see an x. Similarly, right here, f of -1 means what do you get when you plug -1 into x. So let's go ahead and find those. We'll find f of 3 first. F of 3 looks like this. 2 times, instead of an x, I plug in a 3, minus 2. So f of 3 is going to be equal to 4. So let's go over here and look at, on our graph, where that point is. First thing I'm going to do is kind of extend this up a little bit. So on our graph, we just found that f of 3 equals 4. Or in other words, when x is 3, the output for my y is 4. So really what I just found was a coordinate pair. I know that x is 3 and y is 4. So if I go over here on my line and I go over to 3, here's an x of 3, about right here. And if I go up until I hit my line, well, look what the height is. The height happens to be 4. So all this means is when I plug 3 into this function has a height or a y value of 4. This is going to be one of the points on the line. Okay, similarly, I'm going to find f of -1. And again, all this means is wherever I see an x, I'm going to plug in a -1. So I get 2 times -1 minus 2. So I know that f of -1 is equal to -4. So again, we're going to come over here, but remember this was the thing that I put in for my x, and what this function spits out is my output, that's just my y. So if I go over here, I start at 0, I go over 1, so I go left 1. There's an x of -1. And my function, if I go down to where my function is going to have a height of -4, or a y value of -4. So that's really all these things are. It allows us to find ordered pairs. When we plug in an x, it spits out a y, it tells us where our graph is at that particular point. So we want to take this concept of plugging in for x and extend it a little bit. Notice you've got a little bit different looking thing up here. Evaluate f of 2x simply means that when I take 2x and I plug it in for x, they want to know what this new function looks like. So this, just like before, whatever's inside the parentheses, we plug in for x. So we plug in 2x wherever we see an x in that equation. There's my x. So f of 2x just means I've got -2 times 2x minus 2. And we can simplify this. So we look at f of 2x equals, that's -4x minus 2. Okay, so this is the exact same thing. I'm going to take whatever's on the inside of the parentheses, I'm going to plug it in, and I'm going to see how that changes the original function. So we went from a -2x minus 2, and we changed this function into a -4x minus 2. So let's go ahead and plot these two. Let's see what we get. I'm going to do this one in red. And doing this guy in green. F of 2x we'll do in green. Okay, so let's start with the red function up there, f of x. F of x has a y-intercept of -2, and it tells me to go down 2. There's 1, 2, and over 1. Down 2, over 1. So my red line, or the graph of my red function, f of x up there, is going to look something similar to this. Okay, let's check out the green one over here. The green function, f of 2x. We've got an intercept of -2, so that's actually the same. It's the y-intercept. But this tells me to go down 4. So I go down 1, 2, 3, 4, and over 1. So that point's going to be about right there. Let's go ahead and plot our line. So our line is going to look something like this. And if you look at the graph of that line, essentially what hopefully you'll see is that it makes this thing steeper. It makes the original steeper. So if I took this original and instead of decreasing a little bit more flat right here, it decreases at a steeper angle. And that's generally what happens. So anytime we plug in a number that's bigger than 1 for x, so we basically say, hey, let's let x turn into a 2x. This is going to make this line steeper. So it makes the graph steeper. Alright, so let's check out another one here. This next example, I've got my same line over here. It's the same exact thing. It's got a y-intercept of -2 and a slope of -2 over 1. But this time we're going to plug in a number that is 1/2x. So anytime we see an x, we're going to plug in a 1/2x. So let's check out what this looks like. So f of 1/2x equals -2 times 1/2x minus 2. And let's go ahead and simplify. So I've got f of 1/2x is equal to, well, this is -2 over 1, and we multiply across, so that's -2 over 2, so that gives me a -1x, technically, minus 2. So let's go ahead and plot this thing. So this is f of -1/2x. It's still got the same y-intercept, notice. So it still crosses at the same, but this one's going to go down 1 and over 1. And then down 1 and over 1, and down 1 and over 1. And so this line looks like this. So let's go ahead and plot this thing. This thing's going to look like this. And let's check out what we notice. Hopefully what you notice is instead of like this one, we took the red line and it kind of made it steeper. It made it decrease quicker. This one actually goes the other way. So it flips it up so that it's now flatter. So what we did again was we kind of shrunk down the slope by multiplying it by a fraction, and it makes the graph or the line flatter when you do that. Alright, almost done here. Just two more quick examples. So we want to evaluate f of x minus 1. And this is a little bit different from what we've known. We're not actually plugging in here. All we're going to do is we're going to take whatever f of x is worth, which in this case it's worth -2x minus 2, and we're going to subtract 1 from it. So let's check out what that looks like. It looks something like this. F of x minus 1 equals whatever f of x is, so that's your -2x minus 2, and I always suggest you use parentheses, minus 1. And that's really all there is to it. So from here we want to simplify. We know this is -2x, and I've got a -2 and a -1, so that becomes a -3, and that is f of x minus 1 equals -2x minus 3. So we get a little different function. It's similar, but a little bit different. So I'm going to do this one in green again. There's my function. I'm going to go down 3, plot that point. And then this tells me to go down 2, 1, 2, and then over 1. And then down 2, and over 1 again. It's going to put me about right here. And we can actually go in the other direction too. We can go up 2 and over 1. And it puts us about right there. And let's plot that line. So that line looks something like this. There's my green line. And it's a little bit off. Let me fix that, just so we can make sure we see what we should see. So what you should see is something that's almost the same exact line, but it's shifted. And the way that it shifted is essentially, I just took this line and it shifted it downward. And if you notice how much that went 1 unit. So what this does is, if you're going to add or subtract a number to an entire function, this actually shifts it, in this particular case, down. But we'll see here in a second that we can also shift it up. So this shifts it up and down anytime you add or subtract a number to an entire function. So last one here. Evaluate f of x plus 3. Notice last time we did minus 1 and it shifted it down. So this time we're going to do plus 3. And again, f of x plus 3 equals negative 2x minus 2. That's f of x. That's in place of this. And we're just going to add 3 to it. So that's going to equal negative 2x minus 2 plus 3 gives me plus 1. That's f of x plus 3. So let's do that one in green. And we're almost done. Y-intercept is 1. There's my y-intercept. And I need to go down to 1, 2, over 1. 1, 2, over 1. And let's plot our line. And that line looks something like that. And again, you can tell, same relationship here. Only this time, instead of shifting down down 1, we actually shifted up 3 units. So there's my 3 units. I took my red line and I shifted it upward, and the way that we do that is we add something to a function.